Alright, in this video, I'm going to go back through the three basic trig ratios that you've learned. Now, I wasn't here the first day you were taught this, and let me just show you something real quick. So, about trig, how it all came into being, everyone noticed, and we've talked about similar figures in here before. Remember, similar figures have the same shape, they're just a different size. So a long time ago, some mathematicians noticed, they said, well, what if you take a bunch of different right triangles that are different sizes and look at them? And they did, and they noticed that, it turns out that all right triangles are similar. Makes sense. Same shape. 90-degree angle is a 90-degree angle no matter where you put it. So they're all similar. And then they came up with some real neat facts about it. They noticed that every time you looked at opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent, if I looked at all three of these ratios in this triangle, or the small triangle, they noticed that they always end up being proportional. So looking at that, they noticed that these three ratios right here were very, very, very special. But this is a mouthful, y'all. They said, I don't want to have to say this every time I talk about this ratio, or this one, or the last one. So they came up with three things that you now know. And we call those trigonometry. And the three that you learned are tangent, sine, and cosine. Now, mathematicians are still very lazy, so we like to even shorten those words. So we like to say tangent, and we say it's opposite over adjacent. Then we shorten sine to sin. We say that's opposite over hypotenuse. And then cosine, we shorten that sucker down, and we say that's adjacent over hypotenuse. So anytime I'm referring to these very special ratios, instead of having to say that thing every time, I can just say cosine, sine, or tangent. So let's look at a right triangle here. So I have a right triangle. I'm going to put some degrees in here. Let's say 30. No, I don't want to use 30. Let's go with 40. And 50. So we can set up the ratios in these kind of problems. Okay. So let's go with 3, 4, and 5 for this right triangle. So guys, it all depends on where my reference angle is. The setting up of trig that we did on the first day is just that. You're setting up the ratios, you're not doing anything with them. Later on, we looked at later in the week, this previous week, where we actually took those ratios and either did inverse trig to find a missing angle, or we used that ratio to actually find a missing side. So let's say I'm going to use, this time, 40 degrees for my reference. So I'm going to do sine. Sine of 40 degrees. Let's see. Opposite over hypotenuse. And I think this is still what y'all are having a little bit of trouble with. Guys, the first thing I can always find in a right triangle is my hypotenuse. It's always across from, opposite from that right angle. Now, if this is my reference angle, the adjacent side is going to be the side that's right next to that angle. Well, it's got to be this one. Then the side opposite or across from that angle is down here. So since sine is opposite over hypotenuse, the sine of 40 degrees situation would be 3 over 5. Right, let's even simplify the process even further. I'll leave the numbers. I'll erase the angles because I'm not worried about the angles right now. And now I'm going to change my reference angle down here. Sometimes if we're just wanting a generic angle, we like to use Greek symbols. Theta is one of our favorites. So looking in this problem, since I've switched our reference angle, it's going to change some things. So this is still my hypotenuse because it's across from the right angle. My adjacent side now is down here because that's my reference angle. The opposite side is over here. So now let me find the other two. I'm going to say cosine theta is equal to adjacent over hypotenuse is going to be 3 over 5. And again, these are the same because I switched the reference angle. Tangent of theta is opposite over adjacent, so it's going to be 4/3. This is just setting up, or we call finding sine, cosine, and tangent. Now that we know how to set up our trig ratios, let me show you some of the useful things that we can actually do with it. So here I have a right triangle. If I told you to find out what theta is, it's going to be kind of hard to do with what you've been taught in the past. The only thing you know about angles in a triangle that I've really taught you how to find is all of them add up to 180 degrees. Well, that's kind of hard to do here because all I know is one of them. So if all I've got is, well, 90 degrees plus a theta plus a who knows equals 180, it's kind of hard to find theta when you've got that extra variable in there. So the 180 won't work. So trig is another way that allows us to find missing angles in a triangle when knowing that all angles add up to 180 falls apart. So looking at this, if this is going to be my reference angle, over here's my opposite side, adjacent side, and this is my hypotenuse. Now you have to get better at deciding which one of those three trig values is going to be helpful, sine, cosine, or tangent. Well, let's see. I know my adjacent side, it's 33. My hypotenuse is 57. The only one that pulls in both of those sides is cosine. Now, sure, I could use Pythagorean theorem and find this one over here, but why? The problem isn't asking me to do that. So I'm going to use cosine theta. I'm going to set up that ratio. It's going to be 33 over 57. Now, theta is going to be equal to inverse cosine 33 over 57. This is the part where a calculator is most useful. We're going to round to the 10th place in this. So you take your calculator and you're going to do 33 over 57. And I'm getting about 54.6 rounding to the 10th degree. Now, depending on your calculator, you have to enter this in different. If you're using one of the Inspires that we have, you can put it in exactly the way you see it right here. But again, it just depends on what kind you have, and if you're unsure how to use yours, then come see me. Okay, so here's a here's another useful thing that we can use trig for. So if I've got this problem, some generic right triangle, and they want me to find x. Well, the first thing I always want to try, I want to see if Pythagorean theorem can work. Now, I'm going to be honest with you, I prefer trig when I can use it. To me, it's a lot quicker. But I know some of you like Pythagorean theorem. It could be an option. Let's see. I know this side, but I don't know that side or that. I don't have enough info to use Pythagorean theorem. Whenever I'm caught in a situation like that, I want to look at geometric mean. I don't think that's going to work either. So I think trig may be a pretty good option. So, since they gave me this angle, I'm going to use it for a reference. Now, of course, this time I can go 180 minus 62 minus 90 and get this third angle, but why? They didn't ask me to do that. So I'm just going to use what they gave me. And now I have to decide which trig, cosine, sine, or tangent is going to help me. Well, let's see. That's my reference angle. This is my opposite side. This is my adjacent side. And this is my hypotenuse. Let's see, it looks like I'm given the opposite side and I need to find the adjacent side. It looks like tangent is going to be my best way to go. So I'm going to say tangent of 62 degrees is equal to opposite over adjacent, so 16 over x. Now, and again guys, tangent 62 degrees is just a number. If you punch it in your calculator, you're going to get some kind of decimal. It's a weird looking number because it has words in it also, but it is. So I'm going to put it over 1. Equals, oh great. Now I have a proportion. I'll solve it. Cross multiply x times tangent 62 degrees equals 1 times 16 is 16. Now, if you watch the other video on this, where you see that woman solving this, she goes ahead and punches this in and rounds it off. We're not going to do that to the very, very last step. So since this is just a number, and I want x by itself, and this is an equation, I'm going to divide by that number. Looks weird, y'all. Just bear with me. That goes away. X equals, and remember, I've got to do it on the right side also. So, this looks like x is going to be 16 divided by tangent of 62. So, and again, it really depends on what kind of calculator you have. On the Inspires, how you're going to do it is make a fraction, control division, 16 in the numerator, drop down to your denominator and put tangent 62, enter. Again, for these examples, I'm rounding to the tenths place, so it looks like x is about 8.5. Again, I don't need a degree symbol here because I found a side, not an angle. Again, this is a second very crucial use of the trig that we've learned so far.